Knee boy.
We're sorry you're hurt.
I hope you feel okay-ish.
Miss Evans forgot to record.
But
I
I'm recording for you
remember.
now. I was gonna drink cold or fake.
Okay, now you're caught up where we're at. Okay, go ahead, Miss Evans.
Alright, this was a problem we did. We set them equal to 0 so that we didn't make a 0 at -2. Oh, I'm sorry. This is this graph. You can look at it for another second. Alright, so we're moving on. Alright, so what happens if we have, I give you an equation like this. Y equals x to the 7th minus 4x to the 5th plus 3x minus 2.
We cried just a little. Yes.
You cry just a little. I mean, and what the book does is they give you a random curve that doesn't show really anything, and they say which one of these would graph to this. Okay. So, what are some things that you automatically know about this graph?
It can only turn 13 times.
No. Degree is 7.
Oh, it can only turn 7 times.
It can actually only turn
6. I'm at 6. I'm at 6. I'm at 6.
at most 6. So you're looking for the highest degree. That's the degree of this function.
So any of the ones that don't go 6, roll it out.
So it can have at most
Or
6 turns. Okay, what else?
It's gotta go like negative and then the positive.
It has to start. It's an odd degree. And it's positive. It's positive. So it must start here. It can make some turns, but it has to end going up. Okay? That could be a random sketch of an x to the 7th graph.
Is that positive in parentheses?
Yes. Sorry, I just realized I did not end my parentheses. So this has how many turns? 1, 2.
How did you determine it was positive?
There's no negative in front of it. Literally, your highest degree is there a positive in front of it or is there a negative sign in front of it. In general, I like positives.
Me too.
Your book sometimes throws negatives in there.
Well, that's why I don't follow that.
What about this? Why?
You get a cash refund?
What?
It's like 5 cents.
Oh.
Negative x to the 6th minus 5x plus 2.
Wait, are we not graphing the other one?
I did.
Well,
It was a random graph. It's just literally a sketch. It has to start low and end high. Okay? It only has 4 turns. I could have made one more parabola type thing inside of it. But it doesn't have to have 6, but it cannot have more than 6. Okay, next one.
Well, I know it's negative.
So it's negative.
5 turns.
You can have at most 5 turns. It's an even function. So even functions, whatever way they start, they have to end the same direction. So that means they have to start and end the same direction. Okay? So how might we sketch this? Being negative, think of parabolas. When you think of even functions, think of parabolas. They always are going up. So when you see a negative, it's going down. It's the frowny face. Okay? So it could come up, up, up. Whoa, 1, 2, 3, 4, 5. There we go. Because it's negative, it's going to be facing down. Because it's even, they're going to go the same direction.
Spooky.
2, 3, 4, 5 turns. There is one more thing you can find with these. There's always a y-intercept. But They did not put these on these graphs when they just sketched them. But that's something you can determine.
If it says sketch on my test and I give you that, it might be
It's
able
Calc.
to get it right.
See what they did in the book?
So yes.
I mean, like,
they didn't put like numbers or anything. Okay, cool.
on these. If it specifies, I will ask. Okay? Because we will get a little bit more specific. Last but not least, g of x equals negative x to the 5th plus 10x to the 4th minus 3rd. Why do they give so many things? X squared minus 24x. It is annoying. Because really the only thing we need to know are these things. Dealing with that very first function. What do you know?
4 turns.
At most, 4 turns.
It's negative.
It's a negative function.
So it is odd.
It's odd, meaning it will start and end different directions.
I'm guessing it's a fairly volatile graph because everything else is actually 4th, x to the 3rd, x to the 2nd.
Mm-hmm. It does. I mean,
So the crests are kind of right.
yeah. So all odd functions from x cubed on, even x to the 1st. I mean, think about that. It's a linear function. Okay. I mean, they go opposite directions, and all positive ones go uphill. So negative ones go downhill. So we would start up, and we can turn. Yep, that's as most as it can have. Okay, so we can have 1, 2, 3, 4 turns. We have to be going opposite directions. Okay, that's just how we see it. They give you the big long formula. An in-depth study of polynomial function reveals several interesting but seldom discussed properties of polynomials. The general form of an nth degree polynomial is lots of things. Ax to the n plus bx to the n minus 1 plus cx to the n minus 2 plus ... k. The sum of all the roots. This I did not always think was important, and then it came back to bite me once that we didn't talk about it. If you have a function somewhere, the sum of all the roots is negative b over a. There's somewhere else that we have a b over a.
I'm
No,
good.
it's b over 2.
Is it
What?
oh my goodness gracious, it's when we're graphing something and it's like eclipse and like hyperbole, something like that. I don't know.
Mm-hmm.
That's just what I remember.
The sum of all the roots is negative b over a. The product of all the roots is k over a. If the degree of the polynomial is even, if the product is negative k over a, then the degree of the polynomial is odd. I don't know, I forget exactly, because we don't ever get to the really, really yucky stuff. But I remember this. If you want, it's an x bar. It's like an average. The average value of all the roots is called x bar. It's equal to negative b over n a. Your exponent. It's the average. And somewhere we're going to have to know that. And then I'm going to be like, wait, where did we see that? All the roots. And then they ask you to sketch one and be a little bit more specific. if you have y equals negative x cubed plus 3x squared minus 2x plus 3. And it says sketch the graph of. Now, say every cubic function, or every odd function, has at least one real root. Do you know why every cubic function has at least one real root? It's because it has to be going up and down. It always has to end in opposite directions. Even functions can do the waves above and below and never go to the x-axis. But if it's a cubic or any odd function, it always has to start one direction and end the other. So it's always going to go through the x-axis somewhere. Okay? So we just need a rough sketch. We don't need to search for this root. The x value of the inflection point. That's what it is. The inflection point. We'll talk about inflection points. I don't know why they don't just say that to begin with. The x value of the inflection point is the negative b over 3a. Does everybody see our 3? Negative, and then we have b over n a that we have up here. So our negative and our b is 3. Our n, you see our n is 3, and our a is negative 1. Which I think we all see that as negative 3 over negative 3, which I think is a positive 1. So there is an inflection point at 1, if x is 1.
Wait, where'd you get the 3 and the 1s and stuff?
Okay, so this is my b,
Okay.
this is my n,
Okay.
this is my a.
Oh, okay.
N is your power, whatever power you're going to have.
Of your A term?
Mm-hmm. Whichever one comes first. You always have to have the degree order also. Okay? So, if we plug x in, so this is our x for our inflection point. So if x equals 1, what does y equal? So now I'm going to plug in y equals negative, and then I'm going to plug x equals 1 in for all of these. Plus 3 times 1 squared minus 2 times 1 plus 3. 3. So I'm doing math really quick in my head. Did we get 3? Yes. 3 minus 2 is 1. Negative 1 plus 1 is 0. Plus 3. So y equals 3. So we actually have a point that we know on our graph. Wow. Is there another point we can know? What happens if x equals 0? If x equals 0. So if we plug in a 0, or we plugged in 1. 0, 0, 0. How in the world is that possible? Our y value is the same, and our x values are different. Because it's gone up or down. Okay. Let's have a rough sketch. Rough, less rough than the ones we just did a little bit ago.
But I can't
I can't graph.
graph. You know that. So they all look rough.
They all look rough. But we have 2 points we can graph on here. And some things we know. We have a 0, 3. And we have a 1, 3. we know it's a cubic function, so it's going to start one direction and it's going to go the other direction. We know it's negative. How many turns? At most, 2 turns. It's an odd, so it has to start and end opposite directions. So it's this or this. Oh, really bad. So one of these two, but it's negative. So it has to be that one. So it has to start up, okay, and it's going to end down. And we really don't want to even go through factoring to find out where our 0 is. We just know it's coming here. It's got to go through this point, and then it's got to go through that point. Okay? And this point, this inflection point, is going to be either the top or the bottom of a parabola, of an inflection point or a turn. So, if I'm turning here, that does not mean I'm going to take that away. I'm going to start over. Maybe I won't. Never mind. But I don't want to go that way. Why am I keep doing the same thing? Let me just erase that. So I want to go this way. So 1 there. That's what I want to do. Now, is this 100% what it looks like? Maybe, maybe not. I just know that this has to be the top of a type of a parabola. So that's kind of how I went. Keep going. They do 2 different pieces. And that's all they talk about within this lesson with that. I think we need more of them.
Okay. We're almost out of time.
We're almost out of time. We have almost 7-10 minutes. I do. But it's at 11. It'll be okay. It'll be okay.
How fast will that drain? Like in this class period or?
No. I mean, we've got 8 minutes. It'll still be at 3 or 4 by the time we're done.
What happens if it dies? Does it just take forever to start back up?
No, you just plug it in and it starts right back up.
No. Your phone.
My phone. Because it's like a point where it won't hold battery anymore.
Mine doesn't charge half the time.
Sometimes I'll be doing something, I'll have phone with it plugged in, and it will continue to decrease until I drop my phone with the case on, and the back of my phone cracked. With the case on. I was like, why did
So
I
I went 2.5 years without a case, and I still don't have a case. So I dropped my phone like for the first time significantly in the Frankfurt airport, and it cracked.
I can't do without a case because every time I've done without a case, it just doesn't end well. We all know it. I've had my phone fixed like 6 times. And it's just not a good time. So
See, I like live on the edge like that.
I'll just keep a case on it. My case is broken right now because I've taken it off too many times. So like the edge part has broken off. It's great time.
We're just going to do 3 through 9. This from lessons that are the sketching the graph. Number 4, it says, use your knowledge of polynomials to make a rough sketch of the possible shapes of the graph.
So I'd say I made a bunch of friends in Europe.
Do what?
I made a bunch of friends with Europe.
Cool.
Last night I messaged with a guy from Poland on LinkedIn because I didn't have an email. He responded with 3. One of them was the CEO of Sony Music Syndrome.
Oh, wow.